The present discussion, we have to talk about Meson theory. It's a known fact that a nucleus is composed of positively charged protons and electrically neutral neutrons. Rather than experiencing electrostatic repulsion between the positively charged protons, a nuclear force operates between them. To address this, it is essential to explore Meson theory. Photon is a fundamental unit of electromagnetic field. Likewise, meson is a fundamental unit of nuclear field. Inside the nucleus, the exchange of mesons between the nucleons is responsible for nuclear binding energy. According to Yukova, mesons can possess a positive charge, a negative charge, or be neutral. If you consider the pi mesons, they may exist in pi 0, pi plus, and pi minus. Furthermore, their spin value is 0. The meson exchange is possible within a short range, otherwise, the principle of conservation of energy will be violated. The mass of the meson is estimated using Heisenberg's uncertainty principle. If del E is the response energy of the pi meson, then this energy must be exchanged between the nucleons in a time delta t. According to uncertainty principle, delta E into delta t greater than or equal to h cross. The distance that a meson is to travel in time delta t should not exceed the distance between the nucleons. That is, range is 1.4 into 10 power minus 15 meter. If velocity of light to be the velocity of meson exchange, the value of delta t is equal to r by v. We know that velocity equal to distance by time, but time equal to r divided by v. This is 1.4 into 10 power minus 15 meter divided by 3 to 10 power 8 meter per second. So we can get delta t this much. Then delta E equal to h cross divided by delta t equal to 2.25 into 10 power minus 11 joule. To express the energy in terms of electron volt, divide this value by 1.6 into 10 power minus 19. Now the energy is 140 MeV. This is the energy of the meson. Using the formula E equal to mc square, we can express mass of the meson in terms of energy. That is E divided by c square. So the mass of the meson is 140 MeV by c square. Usually we are expressing the mass in terms of energy alone. That means 140 MeV is the mass of the meson. Mass of the electron is nearly 0.5 MeV. Actually, this is MeV by c square, but usually we are saying 0.5 MeV. Therefore, mass of the meson is 280 times greater than the mass of the electron. Here the mass of the meson is 140 MeV, but the mass of the electron is 0.5. If you multiply 0.5 by 280, we can get 140. The experimentally measured value comes out to be 270 times greater than the mass of the electron, which is in close agreement with the theoretical value. The emission of beta particle by a nucleus and consequent conversion of a neutron into a proton in the nucleus takes place when pi minus meson is ejected. The pi minus meson decays almost instantaneously and appears as an electron outside the nucleus. Here, neutron is converted into a proton with the emission of pi minus. Then pi minus is immediately converted into an electron with the emission of antineutrino. Here, the emission of a positron is given by the relation. Proton is converted into a neutron with the emission of pi plus. Then pi plus changes into a positron with the emission of neutrino. The exchange of meson of mass m give rise to a potential called equipotential whose value is pi equal to g e power minus alpha r by r. Here alpha equal to mc by h cross. If m approaches 0, then this equipotential is reduced into normal Coulombic potential. You know that anything power 0 is 1. So the e power minus alpha r factor is approaching unity. Then pi is equal to g by r. This is our Coulombic potential. Therefore, only due to the exchange of mesons, nuclear force is always existing between the nuclei.